Hello everyone. So my name is Jashwant Verma. Now I will explain the problem. Statement is about on count subsets. So let's go to the problem. So in this problem, so they have given array contains n positive integers. They are positive numbers. So your task is we need to divide the array, like partition the array into some some subsets where each element in subset will follow some specific constant. The constant is every element in the subset or subset which is must be greater than equal to the respective index. So your task is your task is we need to minimize this partition. So for this, let's consider an example. Yeah, so let us consider example is 616. Let's consider this array. So first what I am doing is first uh, I sort the array, so in ascending order. Then I got like this. Then after that, what I'm doing is I need to create one method. So that method is helps to we need to create subsets. So I previously mentioned that they have one condition is every element in that subset or subarray which is greater than or equal to the respective index. So first one initially consider one subarray. So initially is empty. So the first index, let us consider this element 1. So I need to this one element is 1 which is greater than equal to their index. So they mention the problem index is of array started with 1. So let us consider 3, 4, 5, 6, 7 and 8. So now I'm creating a new subset. So let's start. So first initially the set, like not set is a subarray. Is initially it is a empty. Then I need to add the first element, so 1 which is greater than equal to 1. So then add it. Then I need to consider another element, so which is, so when I want to add the element in this array which is greater than equal respect index, so the next index is 2. So that means what kind of element we need to add now in this array which is always greater than equal to index of 2. So now check it, 1 is less than 2. Then no, it is not possible. Then you go to next. So next element in the array, then 1, again 1, it is not possible to insert this position. Then you go to next. So 2, yes, 2 is greater than equal to this position, like greater than equal to the index. So it starts with this root. So now it added into the array. Then now index is third. Now index will go to 3. Now you need to check on the next element. So 3 is satisfied the condition because of the current index 3 and our element is 3 is valid. So now add it into array. Now index is go to 4. So now go to index 6. So now go to the index 6 and the element is 6. So 6 is greater than is equal to your current 4 because of the required element is greater than equal to 4. So this element is meet your criteria. So now the set this element. So 6. Then go to the next element. So that element is inside index 5. Then now to get next element, that element of 6. 6 is greater than equal to 5. So that is meet your criteria 6. Then you go to the another element, so which is next to index 6. So with 6, next element is 6. 6 is greater than equal to 6. Yes, again it's meet the criteria. Then you add it. Then it comes out of your index. So no element is added to in this array because of when you want to add this element in this your current array index is 7. So next element is must be greater than equal to this index 7. So there is no elements array, so no need to add any elements. So this is your first subarray or subset. So next we can start another. So in this case we have remember one case. Remember one thing. So what kind of elements are will be added in this subarray? These elements are not repeated into another subsets, right? So what I'm doing is I remove the what kind of elements are inside this array. That elements are removed from this your main array. So now I remove all these elements. So 1, so 2, and the 3, and the 6, and the 6, and the 6. Now remaining element of array contains elements are, so the original contains only two elements is 1, next one is 1, So one again we can start the same process. So first initially the array is empty, so that's why I'm add this first element. So one, so his index is 1 because of the meteor criteria. Then I'm going to go to next index, whose index is 2. So index is 2. So whether this element is 1, so 1 is not greater than 2, so no need to add this element. So this is another array. So this is another subset. So we remove this one. So finally we have the only one element. So because of this this element is definitely with meter criteria because of element is 1 and the index also is 1. So 1 is greater than 1, we meet a criteria. So all these elements are removed from this array. So now your main array become empty. So that means you can repeat this adding process until your until your main array, like this array, until the main array become empty. So now we need to count the total number of subsets one generate. This is a one's not this is one subset, another one is under this subset, another one is this subset. So total we have 3 subsets generated. So when compared to remaining all the partitions, under this partition is require minimum number of part. So under this kind of partition requires minimum. So we have many ways. Let us say when consider this partition 1 or 2, this one and this one, and every element will become their own partition. So they requires when you want to divide this array based on their like when you want to divide each element as its individual partitions, and the number of partitions required will be equal to the number of elements in array. So it is a worst case. So in the question they have asked you to the minimum to minimize the partitions, so that minimum number of partitions required to know to divide the array. So that's why I sort the array, then you need to add the necessary index. So then I will show my code how I'm doing this. Yeah, when see this code, first initial take the input and take an array list. So because of dynamic size, and next I sort the array into some ascending order. Then I need to create a loop which is previous said that. So this process has been continue until the array size is empty. So that's why I take a loop which is repeated until the size is I mean the size is not empty. So I take and I create another array list is temporary, which is store your temporary, like this one. This array list will also to store your temporary data, like, and after partition what kind of elements are will be remaining, that elements are will be added into this array list. So then I create one method create. This method will create your subset is nothing but they have followed the order but not in continuous, but subarray is nothing but is a continuous manner. So next, so in this I have explained that. So first initially I pass in any your main object, like main or array list. Then you to initially consider index as 1. So then I repeat then you satisfy the conditions whether the element is greater than their index. Then add to that element into the your subarray as a subset. Then you will then increment your index. This process continue until enter of array. Once you can be comes out of this for loop, your new subarray has been new subarray or subset has been created. So that subset will return to this method will return that new subset that comes into this one. So then what I'm doing is under the I removed all the elements which have been there in your subset from your original array. Then I need to increment the count because you have created new subarray. So it's about this. So when also time composite of this algorithm. So for creating of the subarray, we need to compare the every element in array up to n. So this means takes order of n first. So then after that order of n. So I remove this one. So first initially we need to create your subarray for every time it takes order of n, and along with for every time I had removed for every time I had removed the elements. So this one. So for every time I had removed the elements from your original array. So the time complexity for every element want to remove in our array list takes order of n. So when you consider worst case, we have n elements were removed from original array. It takes order of n square. So it takes order of n square. So that means now and your overall time complexity is order of n square. So this one, and when you say space complexity, so here I'm considering an stray array list. So it takes order of n. So that means the space complexity of this one is order of n. So the space complexity of this algorithm is order of n. So that's when the time complexity of algorithm is order of n square, and the space complexity is order of n square. So this is about. Thank you.